Hello everyone, and thank you very much for being here with me again. Today we continue our discussion about relationships in JPA, and the second kind of relationship we have to discuss about is the one-to-many relationship. Last time we discussed about one-to-one, now we continue our discussion. I have already prepared here for you my IDE with the skeleton example that we've been using throughout the past lessons. Remember that we are here in lesson number 6, so in case you are here for the first time, you might want to check out the previous lessons, otherwise maybe things might not be clear, and some of the stuff that I have already explained, of course, I will not re-explain it each and every lesson. Of course, if you are here with me live, remember that you have a chat there, and you can ask questions, start discussions, say hi. And if not, you can still ask your questions in the comment section, and you can always find me on LinkedIn and X. With that being said, let's talk about the one-to-many relationships. So similarly to the one-to-one relationships, we discuss about classifying them in one-directional and bidirectional relationships. And to make things clear, of course, let's put them in an example. So let's say we have post and comments. Post, like you post something on social media, and comments, someone can comment it. So one post might have multiple comments, but a comment only belongs to a post. That's what we call a one-to-many relationship. So one of the sides is characterized by only one entity, the other one you might have multiple. So one post, multiple comments. One post has multiple comments, but a comment belongs to only one post, so one-to-many. So let's say this is post, and this will actually be my entity. So I have to annotate it with entity and then declare the ID. Let's say I also make it as a generated value with the strategy identity. Identity, please. And the post has a title and the content. And that's it. So I will add the getters and setters. And that's it for the post. And then we have, of course, the comment. So let's create a separate class, comment. And we have the entity annotation. Similarly, I would just define an ID, annotate it appropriately with the ID annotation, generated value, strategy identity. And we'll only have a content, which should be enough, and generating the getters and setters. So two classes, I think that you can see nothing special on this. So let's start with the relationship. How do we make these two entities relate? Remember, when I will probably repeat this frequently throughout the lessons, you have to think in terms of ORM. So don't think in terms of JDBC. As prerequisites for these courses, I told you should know a little bit of SQL and work with JDBC already. But when you work with JPA and any other object relational model, try to model your mind to think in the real way you should do. So one of the things that I told you even last time you saw, one-to-one relationships. Now we have two ways in which we represent them in the ORM. Now we discussed about having the one-to-one relationship between entities, but you have also seen that one-to-one relationships between table can also be modeled as secondary tables. Now, why is that? Why do you have two ways? Because when we work with ORM, and you probably know that also from the previous lessons, we think in terms of objects. And sometimes what reflects as relationships behind the scenes, meaning in the database, it doesn't reflect as relationships in terms of the objects themselves. And in this case, we have seen, for example, for the one-to-one, that you might have a representation as a relationship between objects, but there is also a situation. There are also situations where multiple tables might relate, but you only have in the end one entity, so you don't have a relationship. Now, in this case, specific case, we discuss about relationships one to many. They usually reflect in relationships also in the objects, in the context, in the JPA context, with the exception being what we will talk about next time. When you have a many-to-many relationship, you will see that behind the scenes you will have two one-to-many relationships, but they will not reflect in one-to-many relationships in the JPA. They reflect in a many-to-many one. But in the case of our example now, it will reflect. So what you have behind the scenes as a one-to-many relationship between two tables will reflect in the objects as a one-to-many relationship. So now you have a choice, and actually in case of one-to-many relationships you have three choices. And you can say, I want a unidirectional relationship and I want it from the comment side. I want a unidirectional relationship, but I want it from the post side. Or I want a bidirectional relationship, which means that each side of the relationship knows the other side. This works pretty much similarly to what you've learned in the previous lesson. Being in the one-to-one relationship, you also had a chance to choose one of the sides and have a unidirectional relationship, or represent the relationship throughout both sides and have a bidirectional relationship. Let's start with the unidirectional relationship from the comment side. So if you have such a situation, then what you have to do is you define the relationship here through the object. Remember that when we work with JPA and ORM in general, you have to have relationships between objects, so never use directly the ID, okay? Like Copilot suggested me here. I don't even know why I'm still using that. How do I deactivate it? Okay. Anyway, leave it like this. So, and say post, okay? And then I'm going to say here, many comments to one post. So always when you now you have to figure out what annotation should I use to put over the relationship. When you have the one-to-one, it was easier because you only have one annotation. You only have the at one-to-one, and it doesn't really matter which side you choose. You always use at one-to-one. Now, when you have a one-to-many relationship, you will actually have two possibilities. You are either have to use one-to-many, or you have to use the many-to-one. Okay. So which one do you choose? How do you know if you have to put one or the other? Well, you always start from the class you are in. So you say one comment to many posts. No? Is that right? Is one comment to many posts, or is many comments to one post? I would say is the second one. No, because you have multiple comments to one post. So many to one. Okay, and you see that's working, is compiling. Now if I would have tried to use the one-to-many, of course you can see that if you have a smart IDE today, it will anyway fail. It will not allow you to do that because it's not right. So it knows that, as you will see immediately when using one-to-many, you have to mark a collection. It should be either a collection or particularly defined as a set or list, but you cannot mark an individual object. So that's why it's failing. So I couldn't have used the one-to-many anyway. I couldn't have used it because it wouldn't have allowed me. But why it's important to know how to deal with this is because maybe you will have some I don't know, questions for a technical interview. Maybe you want to get a certification. In such a case, you might not have the IDE, and you have to also understand the logic behind the scenes. So in this case, it's many to one. So remember, the trick is always start with the comment above. So you say many comments to one post. And that's how you figure out which of the annotations, which of the two annotations you have to use to establish the relationship. So now that you have established the relationship, let's say I'm going only to add the many to one annotation here. And then later I will also discuss about its attributes. Let me fill in also the getter and the setter. And going to the main class, I want to really create this. So let's allow Hibernate create the tables for us. Remember, that's something we only do in examples. Never allow Hibernate or the JPA implementation manage the DDLs, manage the structure of the database for you. This is something you can only use in examples to save time, but never in a real world app. In real world applications, always be very precise with exactly the scripts that you run on the database, which change the structure, whatever that means, meaning creating tables, dropping columns, adding indexes, setting foreign keys. Whatever you write like this should only be versioned, and you always have to know exactly the order in which they have been run. That's why for such things we always use dependencies such as Flyway or Liquibase or something similar. I don't know any other example, but if you have something similar, that's fine, but never use Hibernate directly. Never do that, okay? So mind that when I use this, it's only for demonstration purposes. In real life, I never recommend that, okay? Now I'm gonna say post p is new post. I'm gonna just set something here, say set title of the post, no, post 1, set some description for the post. I have no idea why it's so slow. Set some description for the post, and then comment, have a comment. Set this is not a description, wasn't that description? I was content, sorry, I'm sorry. So my fault, here is set comment, set content, set content, okay? Set content, cool. And then comment, new comment, and you say set content for the comment there, so it's content or comment content. Anyway, so did you consider doing a series on Spring Data R2DBC? From what I know, it's not as flexible as using JPA. I think you actually find something with Spring Data R2DBC in my reactive series, but no, I didn't think about creating specific something for that because it's more about reactive than the database. I mean, I don't know exactly what would you put in a whole series. It's more like 1 or 2 lessons about Spring Data R2DBC. So yeah, I didn't do that. Anyway, so and now for the comment C1, you want to set this as being a comment for post P, and that's everything you can do. And then remember, we use the entity manager and we have to persist. Last time I told you about cascading, and you might remember that as an option as well. For the moment, I will start with being plain and simple, so I'm not going to use any cascading or something. That's why if I don't specify on the model the cascading action, remember you have to explicitly write that yourself, meaning I have to persist explicitly both of them. No, even if the post is a relationship to the comment, I still have to persist manually both of them, since I didn't specify here that the post should be cascaded. So I will take that one later. For the moment, I'm just going to persist them like this. And now I'm gonna just run and see what happens. Probably it will fail because I forgot to put them here. I just copied the way it was last time, but remember, you always need to specify the managed classes. Yes, when you use Spring, for example, that will come out of the box. But here, because we only have a Maven project with Hibernate, you have to explicitly specify the entities. So that's why we will have a large exception here. To solve that, let's add the entities we have. This other one we don't use, we can take it out. And now probably it will fail because I think it already compiled the stuff when I've been adding it. And yeah, it failed, but now when I run it again, it should work. So let me run it again. Okay, come on, faster, faster. We want to see something. We want to see something. Which is mainly what we want to see is the structure that comes in the database and the fact that things worked. Okay, we can see it, so we can go back to Workbench. In my case, the two tables have been created. I'm gonna check every one of them, and you see that post and comment have been correctly set up. So being that the ownership of the relationship is the comment, sees it's where you have the foreign key. You being a one-to-many relationship, you always have to have it on the many side. That's something you should know from basic SQL, so, or SQL, whatever you want to name it. So you can't have it on the other side. When we discuss the one-to-one relationships, you could have it on either side, but now it's always on the comment side, in this case being the side with many, where you have one post but many comments for that post. So the comment itself will hold the foreign key, meaning the comment, this comment is a comment for post with ID 1, which is the post that you can see here. So nothing special, because in terms of the database, you could see everything. The name of the foreign key could be something you might want to check out, is the name of the entity underline the name of its primary key, so post underscore ID. You can change that the same way you've learned to change it for one-to-one relationships using the join table annotation. So let me drop these two tables. Let me drop them and refresh to make sure they've been dropped. And I'm now going back to my comment, and then I will add here the join column annotation. And then you can specify some other names. So for example, if you don't want post underscore ID, which would be the default name of the entity, underscore its primary key, and you simply want to name it post, then that's how you do it. So you use the join column annotation, you override the default name, and if we run it again, we should see that it creates the same kind of relationship, just the name of the column will be differently. Remember never to make confusions between join column and column. Column, the add column annotation is always used on an existing column which doesn't represent a relationship. It's just a column of that specific entity. So for example, I can use the add column annotation for this content attribute, but when it comes to objects representing relationships, join column is always used on the ownership side. It's where the foreign key is. So in my case, the comment, and in a case of a one-to-many relationship, the owner of the relationship will always be the side with many, because you can't do it otherwise. So the comment in my case, because you have many comments for one post, and the join column is the one to use to override the foreign key column, which in my case now I named it as post instead of the default taken by Hibernate or by any JPA implementation, because it comes from the specification, which would have been post_ID. Now it's only named post. So you can do that. You can have different names of your foreign keys if you want. Now, I think this relationship, this one-to-many relationship, this way of writing the one-to-many relationship is likely the easiest. That's why I also started with it, because you are here on the ownership of the relationship. You know, you can use the join column the same way you've learned from the one-to-one, to rename or to maybe alter anyhow, let's say, the foreign key column. And yeah, of course, same as in the case of any other unidirectional relationship, the things that characterizes this kind of relationship is that now when you write a query, you can only write it from this side to refer to the relationship, because that side, the other side, the post, doesn't know anything. It doesn't know it's in a relationship with the comment in this case. So good. So that's basically the easiest way. Now let's switch it a bit. I'm gonna take this out from here, and I'm gonna discuss about the second way of writing a one-to-many unidirectional relationship, which is from the one side, which is from the opposite side of the relationship ownership, which is a little bit trickier. You will see immediately why. Because now I'm going to the post. Now I am on the opposite side. Remember, in the case of one-to-many relationships, you don't have a choice to choose. Like you had in the one-to-one, you could choose which is the ownership. You can say the ownership is one or the other, because either way, it's just a column that will go to one of the tables or the other, and it always works because every side has only one, so it's no difference. But in case of one-to-many, you can choose. You always have one side of the relationship, one owner, and it can't be the other. So in my case, post and comment is always the owner. Whatever I would choose here, I can't make post to be the owner, because you can't store multiple values in only one column. No, so you couldn't store here in the post the relationship to the comments. Having multiple comments, you can't have one column storing multiple values. So you always have in the one-to-many on one specific side. Okay, so what happens if you try to say here, hey, this is the list of comments, and in such a case, remember the strategy. So one post to many comments, one to many. Okay, and one to many is always on the opposite side of the relationship ownership, which makes sense again. So because you will be in the one side, so you are on the opposite side of the relationship ownership. So now the point is, how does Hibernate know in such a case where to actually not exactly not where, but how to create, maybe is best, how to create the foreign key itself. And let's see what happens if I have something like that. So I have the post and the post and the comment, but now the comment is so now the post is the one having the relationship. So yeah, let's just say list of C1, meaning I'm adding the list with one comment, could have been many, as the comments of that specific post. And I'm running this example. Okay, so now you will see something that will maybe surprise you, and that is you don't have only two tables anymore. And that should be surprising because you still have a one-to-many relationship. So you see, you have, in this case, from the context side, a one-to-many relationship, but from the database side, you have a many-to-many relationship in this case. And that happens because there was no way for Hibernate, in this case, to know how to create the foreign key, because you establish the relationship from the opposite side of the ownership. So what the implementation doesn't know is how to work with the ownership when you are on the opposite side of the ownership. So what happened is it said, okay, if I don't know who is the owner, then I will create a separate table to hold the relationship. So I know which are the entities. I know there is a relationship between them. I know which instance relate to each other because we added it in the list, but I don't know how to create effectively the relationship. So what I do is I create a third table, which is called a join table. You know it from the, if you have the SQL basics, you know about the many-to-many relationships, which we will discuss in the next episode, actually, in terms of JPA and Hibernate. But in case you have a many-to-many relationship, then you have a join table. But in this case, normally you don't have a many-to-many relationship. However, because the JPA implementation didn't know how to create a relationship, is simply create the join table. That's why in the real world you should never use the one directional relationship on the opposite side of the relationship, or if you use it, you should always specify which is the join column, which, as you will see immediately, you can do using the join column annotation. But never do things like I did here in my case, where I haven't specified anything, okay? So, being that I didn't specify anything, this is what happens behind the scenes. You need to have a join table. Now, I'm gonna delete all of this, and I'm gonna show you, if you really want to have a one-directional relationship that happens from the opposite side of the relationship, sorry for that, I'm gonna drop the tables, here it is, you always have to use the join table, the join column, sorry, annotation, and specify whatever name you want, but you always have to use the join column. This would be, I hope I'm not wrong, but this would be the only place where you can use the join column annotation on the opposite side of a relationship, because in all the other cases, when you see the join column, it should always be on the ownership side of the relationship. Okay, so this is an exception, and this exception helps you have a relationship, a unidirectional relationship, which is, however, from the opposite side of the relationship with a one-to-many, and it only happens for the one-to-many relationships. So let me take some questions. Will you touch upon anti-graphs in series? Maybe. We will see in some next episodes. I'm a bit confused. I used to think the owner of the relationship is annotated with one-to-many, and it always makes since in your case a post has many comments, hence the post is the owner. So the ownership of the relationship is where the foreign key is. That's also why we say that the mapped by annotation, the mapped by attribute, which we will touch in the bidirectional, is always on the opposite side of the ownership, and that's why in this case you only see mapped by on the one-to-many annotation. A way to remember this is mapped by is always on the opposite side of the relationship owner, while join column is always on the owner of the relationship. Okay, so I hope this helps. How to know which is the owner of the relationship? The owner of the relationship is where you have the foreign key. In the case of a one-to-one relationship, you can decide. It can be either one or the other. One-to-one, you can have the foreign key in either of the sides. The side where you have the foreign key becomes the owner, but you can have it and you decide which side is the owner. In case of a one-to-many relationship, it's always the side with many, because you cannot put it in the other side. So you can't have the post referring in the database to multiple values. A comment will be able to store the post ID, but the other way around doesn't work. Okay, so in case of a one-to-many, it's always on the side with many. In this case, many comments for one post. Okay, and we can now that we've ran it again, you can see that we corrected the anomaly, I would say. You don't have a join table anymore, which is natural, because we don't want to have join tables when we deal with one-to-many relationships. So remember never to get into this anomaly. If you want to have the relationship, if you want to have the relationship from the opposite side of the ownership, then always use the join column ID annotation to specify the name of the ID, and this way the JPA implementation will know how to create the foreign key on the owner side. So that's the two ways of writing unidirectional relationships with one-to-many unidirectional relationship with Hibernate, with any JPA implementation actually. Now, what happens if you have a bidirectional? How to create a bidirectional relationship with JPA and Hibernate? So in that case, we call it a bidirectional because you have the relationship from both directions. So I will not only have to have here the relationship. I will take this out because in this case I will not need it anymore. I will go to the comment and I'm gonna add the relationship here back. So I'm saying the comment relates to this post. I'm gonna use the many-to-one annotation. And here is if I want, where I can alter, for example, the default name of the join column. Say I want to name it post. I can do that. Oops. Okay. Also allow me to put back the getter and the setter. And in the post, I'm going to keep that. But very importantly, whenever you have a bidirectional relationship, regardless if it's one-to-one, one-to-many, or many-to-many, which we will discuss in the next lesson, you always have to use mapped by on the opposite side of the ownership of the relationship. So when it's bidirectional, always use the mapped by to specify which is the name of the attribute on the other side. So this is what it maps to. This is post and it maps to post here. Okay, so map by it's essential in such a case. Also essential in the case, as we discussed in the case of the one-to-one relationship, it's essential when you have a bidirectional relationship to correctly establish the relationship, meaning you have to set the relationship between instances correctly in both cases, not only in one of them. If you only set it in one of them, sometimes it works, but you cannot guarantee and the implementation, the JPA implementation will never guarantee you that it works when you incompletely set the relationship from only one of the sides. So that's why you always have to be careful and make sure you correctly put now the relationship between instances in the context on both sides of the relationship. Now I'm gonna delete this again to see that what I created here works as you expect. I'm gonna run it to prove what I'm talking about. Okay, owner has a foreign key, like comment will have post ID, yes. How do I save an entity with such a relationship foreign key? I'm not sure what do you mean of how do you save it? Like use the persist as I'm doing here. That's how you do it. So depending of course on if you have a unidirectional or bidirectional, you have to choose to correctly set the relationship and then persist. And remember, if you didn't use the cascade, which I will present immediately, you need to manually specify the persist operation or whatever other operation. It's not cascading by default, but that's basically how you save them. So you see, you now have again, it should be nothing special, nothing surprising. It's basically the same relationship, the same tables that have been created, and they are storing correctly the relationship between our entities. Are you going to are you using Copilot now? Is this version of IntelliJ? No, I'm using Copilot, but I'm not really using it because I don't really like what it generates. So I won't disable it now, but normally I don't like really use it because I'm not using what it generates. And anyway, it doesn't look like it generates stuff really correctly, so it doesn't look like it's helping me a lot. Going back to the stuff we are discussing. So we learned how to create unidirectional relationships from one side or the other. To recap, when you are on the ownership of the relationship, everything is fine, nothing to worry. You can use the join column annotation to override whatever you want on the join column. When you are on the opposite side of the relationship and you have a unidirectional relationship, always use the join column, otherwise you will end up having a join table, and you don't want that, at least not in a real world app. And when you use the bidirectional relationship, always on the opposite side of the relationship you have the mapped by attribute, and you may or may not use the join column to alter if you want the foreign column. It's your decision on the side of the owner of the relationship. And now let's talk about cascading a little bit. So regardless of whether you choose a one-to-many or a many-to-many, you can decide from either side to cascade operations. So for example, you might want to say, when I store a post, if I have comments attached to it, store also all the comments of that post. So that doesn't happen by default. So in my case here, I really had to put the persist operation manually. Let's take this out, and let's say that let's actually have even multiple to like really see that we have a one-to-many relationship. No, so I have multiple comments and I will put them here. And remember, I really need, if it's bidirectional, I really need to correctly set it so all the instances should be properly linked in the context. If you don't do that, it may or may not work. The implementation won't guarantee you it works. But what I'm gonna do here is that I'm gonna persist only the post, and on the post I'm gonna go here and say, please cascade me the persist operation. And now, even if I didn't myself persist any of the two, they will end up in the database. So I'm gonna again just play a bit with this and take this out so you can see the clean example from the beginning. and I'm gonna run it. And being that I'm storing the post instance, and the post instance cascades the persist operation, all the values that are here will also have this operation applied. So, and you can see also here that the post in the end was inserted, but same were the two comments, because the persist operation has been cascaded. The two instances have been added to the context even if I didn't manually specify that. And of course, at the end of the transaction, they ended up being mirrored in the database. So they ended up also in the database, which makes sense. So this is the cascade, which works similarly as for the one-to-one relationship. Remember, always my advice, you should only cascade those operations that you need to be cascaded. So normally it's a bad practice to use all. If you say cascade type all, that means all the possible operations defined by the entity manager will be cascaded. But in the real world, this could create problems, because at some point someone might want to operate with an instance and they don't want that instance to cascade the operation. Maybe they don't even figure out that this happens, and this could, and trust me, it happens. I've seen that happening. It will reflect into bugs in the end in your application, and you don't want that. So always be restrictive. So if you only need the persist, then only add the persist. If you want only persist and merge, for example, then what you can do is say cascade, merge, and persist. Okay, so you can cascade multiple, but my advice and the best practice is, please cascade only what you need to be cascaded. Specifically, don't use the cascade all. You will see cascade all in many tutorials. That's fine. In tutorials, use whatever you want, but not in the real world. Okay. Many other questions, and I want to answer them. So, what is the difference between cascading types? I guess you figured out in the end. Cascading means applying the operation to the child. And if you have watched hopefully the first couple of lessons on the series, I have started with discussing all the operations of the entity manager. So you have persist, but then you have merge, you have remove, refresh, and all these operations. Well, you can decide if you want to apply them for the children. So all the names here reflect on all the operations that we have discussed in the first couple of lessons, which you either have to write them manually, so you have to persist C1 manually, or you want to avoid having to write the persist or the operation for all of them. You want to have a behavior where if you persist the post, you also want to persist all the comments here in the list. And when I say persist, then you can just apply the same logic to any other operation. But importantly, don't use in real world the all, which would mean actually by default persist and by default cascade any other operation. So be very specific with what exactly you cascade. Also, a very important thing is that when you have a bidirectional relationship, each side has its own cascading logic, which means that in my case here, if I applied a cascading for the comments of the post, and I have a bidirectional relationship, which I have here, observe that from the side of the comment, I don't have any cascading, which is fine, which is if you will apply an operation on the comment, nothing will happen to the post. In this case, nothing will happen with the post applied to the comment. And you can have cascading here as well. And it might be that the cascading here is different than the one you have on the other side of the relationship. Now you have to be very careful and know exactly from what side do you operate, and depending on the side of the relationship you operate, you will have a different cascading logic that will be applied. For my case here, meaning that if I apply remove on a comment, it will remove the post as well. And then depending on how I configured stuff, it might also remove the other comments or not. Or it might fail with an error, because if I don't allow orphans here, like I don't do, the other comments will not be able to be deleted, and then I will end up with an error. So you see, a lot of things can happen depending on how you configure your cascading. Now, normally the cascading should be configured with very much carefulness, and that's why I say avoid using all, and be very sure that you always are very aware of all the things you cascade, and make sure that you cascade them. When you apply cascading logic, you know exactly what you do there. A lot of other questions. So if you extend the entity, how the relationship will be. Let's talk about inheritance in one of the next lessons. It's part of something we will discuss in one of the next lessons. So I will skip now your question because it's a lot to discuss on it, and I feel that the time for doing that today is not enough. It's a subject that I anyway prepared for one of the next lessons. Okay, so inheritance, let's talk it in one of the next lessons. Does the generated join table have its own ID, or is it a composite between? I think that by default, that's a very good question actually, Borislav. I'm not sure exactly if it has an ID at all. I think that it's not composite. I think it actually doesn't have a primary key at all behind the scenes. Because usually join tables, I'm not sure that by default have any primary key. So we can try that, but my feeling is it doesn't have a primary key at all. And yes, that's totally fine. You might have tables without a primary key. So in any relational database, usually you can define tables which don't have primary keys. And I think that's exactly what happens in the case of any join table in general. We can try that. We can see what happens, but I'm almost 100% sure the table that has been generated doesn't have a primary key at all. So I'm at the middle of the stream. Can you explain one-to-many if it's mandatory? Kamil, please take it from the beginning. It doesn't really make sense for me to repeat everything that I have just said in this stream because you joined it at the middle. You can always take it from the beginning. It's free. It will be here also recorded, so do that. It's a lot better for everyone. Is it a good practice to have Cascade on both sides? Yes, I don't see any problem with having Cascade on both sides. Sometimes you need to do something from one side and something else from the other side. You just have to be very careful with what exactly you cascade and how you do that, because the way you the way you configure your cascading will create some specific operation. I think you can have multiple cascade types. Yes, you can have multiple cascade types. I have even presented this, so you can see if you want to have multiple cascading operations, you can put them in an array with the standard array syntax, exactly as you can see here. And I started to learn Spring Boot. Okay, thank you for your appreciations. Will you discuss transactions? I'm not going to discuss transactions here, but you have transactions already discussed if you want in the Spring playlist. So search for transactions on my channel. You will already find videos on that, and I hope they will be helpful. If the join table doesn't have a primary key, is there a way to add one? Well, I guess you can add one. Now, normally you don't do that with one-to-many relationships, but with many-to-many relationships, you will have a join table, and then you will learn that you also have such an annotation which is called join table. Now, to be honest with you, I'm not sure exactly if you can add a primary key, but I'm pretty sure you can add indexes. But remember one thing, it doesn't really matter now from our side, because you don't really care if it has a primary key or not from here. Normally a join table doesn't have to have a primary key, but let's say you want to add it. Does the ORM care? Remember what I'm always telling you. Think in terms of ORM. When you work with JPA, you don't think in terms of tables in a database, you think in terms of ORMs. For an ORM, the join table doesn't exist. It doesn't exist. It's there, you know, it's behind the scenes, it creates a relationship, but for the ORM, it has no importance, or very rarely it has any importance. And being that you don't use this stuff in a real world, which means you never generate stuff like I do here, I'm doing this only in examples. Remember what I told you. In real apps, you use Flyway, you use Liquibase, you manually create scripts, it's your choice, but you never generate them with the Hibernate to DDL Auto. And from that point, does it matter if you have a primary key? No. Yes, you can have a primary key. You create a script, you put a primary key behind the scenes. No one will care, meaning the ORM framework will not care you have a primary key or not, because remember, the join table is not even represented. The only way to refer to a join table from an ORM is the join table annotation, which we will learn in the next lesson most likely when we discuss many-to-many. But even for the join table, having or not a primary key is not that essential. Having an index might be helpful for queries, for the queries it generates behind the scenes, but otherwise it's not that important in the end. It will not impact anyhow the relationships between the objects themselves in the context. So join tables have composite keys as primary key. That should be a case. Maybe not. I told you there are possibilities where you don't have a key at all. And a code review series, I would like to send you what I managed to learn from your videos. So I'm not sure if I understand, you want me to create a code review series? If yes, maybe I will do that in one of the next playlists. Anything else? Yes, I still have 9 minutes, and I want to go now through all of this. And the most important next is the fetch, which you have also seen in the one-to-one we've discussed. And one of the things you know already is that by default, if what you have annotated with the relationship is not a collection, then by default this is eager. So in the many-to-one, you will see that the default fetch is eager because many-to-one, because it's many-to-one, you will always have on something that is not a collection. So the fetch is eager, meaning that, and you will see when we discuss in detail queries, retrieving, for example, a comment will automatically also retrieve the details for the post. If you want that not to happen, you can set this to lazy. It's rarely that you do that honestly with an object relationship, like not a collection one, because it doesn't affect too much like querying. And usually if you do it lazily, you know what happens is when you take the comment, it will take it without the post information. But then if you need the post information for that comment, Hibernate or or any other JPA implementation will just create behind the scenes another query. So you will suddenly have two queries. So you have to be very careful, because in most cases you want to avoid having multiple queries. Putting that on lazy there might be less performant than simply having it as the default eager, which will get the values on your post. So normally what I would do is I would make sure, if I really don't need at all those post details, if I really don't need them, maybe it makes sense to put that on lazy. But again, in most cases, in my experience, putting it on lazy would be less performant than having it like this default eager, which is not applying for the other for the opposite. So when you're on the post, when you're on the one-to-many, you know you will always have here a collection. And by the way, I didn't explicitly wrote here, but you either have something represented using the collection interface or the list interface or the set one. So one of these three. So I used list here, but you can have a collection which is above both list and set. Or if you know that you have only unique values, then you can have the set directly here. Either of these types work well with the one-to-many. You can use one or the other. Always with one-to-many, the fetch will be lazy. So the default fetch here is lazy for collections. And again, in the majority of cases, this makes a lot of sense, because you don't want to fetch all the instances that were related to your specific instance. In many cases, they can be many and you might not need all of them. So that's why the recommendation is you write a specific query to specifically collect only the data you need. Otherwise, you might end up with a lot of memory used and even out of memory problems. You can change the fetch type to eager for a collection, but I do recommend everyone, when you do that, be very careful. You are on a corner case rather than the normal case, and make sure that when you do that, you don't like really fetch all the or too many instances and end up with memory problems because of that. So normally this is not used. I don't say that there are no cases where making the fetch type eager is not a good one. Like I can even have in mind the idea of the relationship between, for example, user and roles. No, when you implement authentication, usually when you get the users, you know 99.99% of cases you need the roles as well. So maybe there it makes sense. This can be an example. But remember, this is a corner case. Normally with collections, the fetch type should remain lazy. The others, you might see they are very similar to ones that we discussed for the one-to-one. Target entity, it's a very old one. It's used to like when you don't specify the generic type, to make sure that you specify the type. Again, not something that's very often found today. Maybe you can find only in very old code. And orphan removal, I will take the opportunity to discuss this maybe at another time. But as an idea, when you have an orphan removal, it means do you allow or not to delete one side of the relationship without the other. So the other side is called an orphan. If you delete it, it's side, something like that. So for example, in this case, you deleted the post, but you still have the comment. If you want or not to allow that, you can specify through the orphan removal. And mainly, I think these are the main things that we need to discuss. I'm still going now to your comments. I see you are a lot of you here, and I see you had a lot of comments, and I thank you very much for that. I love when you are here and you are really active. So I see that people stay here with me. I'm going to take now the last round of questions. If you will still have questions, remember you can always chat with me through comment section or LinkedIn or X. And we will anyway meet again in the next lesson, so you can keep your questions for that time as well if you wish. So you can also manually create join table and use something like composite class. This would be useful when using join tables. As an idea, if you have a join table, I never recommend you to have it as an entity. I've seen that this is an anti-pattern, okay? If it's a join table, it's a join table. So if it's a join table, it's from an ORM point of view, not okay to have it as an entity. you really have to make a difference when thinking in an ORM way between what a join table is and what an entity is. Sometimes I see this mistake made by people who don't really think in ORM ways, and they create entities to represent join tables. But remember, this is not a good practice. So avoid doing something like that. I'm not sure if that was the case for you, but if that was the case, then remember, join tables should be join tables and they should not be considered objects of the context. Will you send your message on LinkedIn? You can. Yes, thank you. Format and JPA creates a join table whenever is needed to repeat the primary key for an association. Well, it creates a join table whenever it needs to join to create a relationship between two instances, and it doesn't have any other way on how to do that. That's quite simple. But remember one other thing. It really doesn't matter when Hibernate creates, it matters when it uses. So I'm now using this property here just for the example. Remember, it's not important. For a real world app, you don't use that. It's the other way around. You create the tables and then you map the objects on the existing tables. It's never creating the tables from Hibernate, okay? Never. So never do that. Okay, thank you for your appreciations, guys. Lazy loading with anti-graph. You mentioned about rows on tutorials. I've seen that used generally many-to-many. Well, it depends. No, using a kind of relationship or the other really depends on what app you create and its business logic. So I can't say which one is a good practice, because there is no such a thing as a good practice on using one-to-many or many-to-many. It depends on what you write there. It depends on what you try to implement, if it's good or not. So it really depends on the case. It's not one or the other better for anything. When I have many-to-many, I modify to two relationships. Is it a good way to do? Well, no. That's a good question, actually, but I will take it in the next episode when we discuss many-to-many. Behind the scenes, you have two one-to-many relationships, but in the ORM, you need to map it as a many-to-many. If you map it as two one-to-manys, then you don't think anymore in terms of an ORM. So normally, in most cases, there is never 100%, but in most cases, trying to map your objects and creating the join table as an entity is not a good practice. So it's not the best practice. It's not an ORM way to work with the data. Good. With that being said, guys, it's already 2 minutes past the time that I have reserved for our meeting today. I hope that you learned today a lot of one-to-many relationships, and I will now apologize to take the chance to continue our discussion in the next episode. Give you also some time to breathe, to digest what we've talked today, and of course remember that the code will be on GitHub later today, so you can take it and use it and try it by yourself. And I'm looking forward to seeing you next time. Looking forward for all other questions that you have. Until next time, I'm saying goodbye. Have an excellent time.